Okay, thank you. Welcome to my YouTube channel, Vincent Online Tutorial. As you have seen the question there, we are going to look at this question. Basically, because of the demand we have for this, we are going to treat basically number 3. Okay, number 3 is just given here. I'll treat number 2. I'm going to treat all the questions, but let's start with this number 3. As you can see, the question there is an experiment. Okay, please. This question is specifically, this question is alternative to practical. It's alternative to practical question. And as you can see in question number 3, say in an experiment, determine whatever. And then the table is there given, and you can see what they say we should do there. I will say we should, we have an apparent depth which is d sub 2 equal to d sub 1 minus this, and then we also have the real one. And okay, let's get started because we are going to handle this very well. And please like and share and subscribe to this channel. D sub 1, so this doesn't matter, they are the same thing. D sub 1, D sub 1, this is a column. This was not given, I added this column. This column was also not given, I added the column. Now, it's a question which was carried out from, it's a practical trying to find out the refractive index of a material. Then the practical has already been done and collected this D sub 1 and D sub 0, and we were asked to solve them, to complete the table and do some other calculation. Now, as you can see, as you have seen the question, then this D sub 2 was not given. They say we should evaluate it. Look at this. Look at the question. Evaluate this sub 2 minus D sub 1. This D sub 2 equal to D sub 1 minus D sub 0. So if you look at the table there, this is D sub 2, which I have formed, and this is D sub 1, and this is D sub 0. So what happened is 6 minus 1.5 will give me 4.5. 7 minus 1.7 will give me 5.8. 8 minus 1.9 will give me 6.1. And that is how this D sub 2 was made. I hope you understand that. Then we go to the next one. The next thing they asked us to do was to make this refractive index. Remember the famous refractive index formula, which is this: the sine of the incident angle divided by the sine of the refracted angle. Then at this point we were asked to make this column which I'm showing you here. And how they ask the question, we say we should evaluate this refractive index, which is given as real depth over apparent depth, and D1 has already been given as the real depth, which I showed you as D sub 1, and D sub 2, which I have already made here. Now what we are going to do is, for every D sub 1, you divide D sub 1 by D sub 2. So 6.0 divided by 4.5, I'll have 1.33. 7.5 divided by 5.8, I'll have 1.30, and all the way I made this table. All right, there are other questions that were added to this problem. The question said we should find the mean. We should find the mean. We should find the mean of the refractive index, the column of the refractive index. And how to find the mean is simple. We just go back to this part. These are the scores or the samples. We find the mean, we say this plus this plus this plus this plus this, divided by the number of the items. The number of items we have 1, 2, 3, 4, 5. So it's just going to be this. Remember, this is the refractive index. Why this one is just n, the number of items. All right, so that was just what I did here, even though I used this method. I just added all of them, this plus this plus this plus this plus this divided by 5, and I have 6.5 from the summation, and I have 5, which is already given as the number of items, and the mean is 1.312. And the next question they say we should do is to find the standard error. And the standard error is given as standard deviation divided by the square root of the number of items. And this is standard deviation, and this is the square root of the number of samples. Remember, this number of samples is just this number of the scores here, which is 1, 2, 3, 4, 5. All right. Okay, so what do we do here? What we do here is simple. We first of all find our standard deviation. And remember, standard deviation is given as this formula. Why this x is given as the I can call this x as my n, the refractive index, which was found from 1 to the number of 5 minus this becomes our mean, where this is the number of samples, and we have to add all this. When this minus this, we square the answer for each of the column, for each of the row. Sorry. Then at this point, I also decided to write this again as another way of writing the standard deviation. So what I'm going to do is remember this value. They are all constants. Remember, look at 1.31, 1.31, 1.31, 1.31, 1.31. They are all constant. Why? Because they are the mean. This is the mean. They are all the mean. So what you do is, for every value of that refractive index, look at what I mean by refractive index. Again, I have to emphasize that. Look at this part. This is the refractive index. So what I'm doing is, what you are doing here is, for every value of the refractive index, you subtract it by the mean and square the value. This minus this square plus this minus this square plus, until we finish all of them. So when we did that, we had this. This is the value of the square of the difference between the sample and the mean, plus this, we divide by the number of items or samples. Then we take the square root of all of them. This raised to 4 minus this multiplied by 13. 13 means when you add this plus this plus this plus this, will give you 13. Why this, they are common. So I factored them out. When I factored them, I have them here. This is this. Now, what else did I do? This is 13. It was 13 here. I converted it to 1.3. 1.3 times 10 raised to the power minus 3. It was 10 raised to the power minus 4. But because 10 raised to the power minus 4, look at it here. But because I have converted this 13 to standard form, that plus 1 we subtract minus 4. Then we'll be left with minus 3, all divided by 5. So I keep on going. When I carried this 1.3 divided by 5, I had 26. I had a value which, when you do this little mathematics here, you have this, and which is 0.1. I think you have to confirm if that is true. Maybe a little mistake, Tabate. It's correct. All right. So after that, the next thing we are asked to do was to find this. The next thing we are asked to do was to find the standard error. And the standard error is given as, this is the standard deviation, which I told you I'm still working on this. Standard deviation divided by the square root of the number of value. What I did earlier was just to find standard deviation. So the answer was 0.016 divided by the square root of the number of sample, which is 5. And this divided by this, we have 7.14. All right, this is 3DI, fractional error. Now, a little work we have to do here. There is something we call uncertainty. Why some textbooks call it error. What does that mean? In real life, it is very impossible, almost very impossible, that a human being will measure instruments very accurately. There may be circumstances, the way you feel, so many factors may be there. Maybe the instruments you are using, may not really be in the very good shape, or because of some interference from the environment, will make you not to get the exact value. Therefore, we decided to say that for every value you measure, for example, if you look at your time, you say, oh, what the time? The time is 3 minutes past 4. That means it might have been that you didn't really get the exact time. So in order to accommodate for the error which you have made, because you are not very exact, that is why we call it uncertainty, not too sure. So because of that, we decided to bring in this value, 0.05 millimeter. Now, this 0.05 is what was added to this mean. This is the mean which we got. So because maybe one thing or the other, we might have made their mean not to, this is the mean, which is the refractive index, may not really be accurate. So we decided to add 0.05 to accommodate for the mistakes we might have made. That is why we say plus or minus could be that. So fractional error is simply that error divided by the actual value that we got. We measured 1.312, then plus this. So what we are going to do is 0.05 divided by 1.312, which is this. That is the fractional error. Then the next thing we're going to do is percentage error. Percentage error is fractional error multiplied by 100, which is this. Thank you.